Dear students, I am Mahesh Javalkar from Maratha Mandal Polytechnic, and today I am posting my 10th video on analog electronic circuits, in which I'm going to tell about how do we use transistor, that is BJT transistor, as a switch. Okay, so here the heading of this presentation will be a transistor as a switch, and the outlines of this presentation are: first is operating modes of transistor. What are the operating modes in which the transistor can operate? Transistor as open switch and transistor as closed switch. Okay. So first we'll go to see what are the operating modes of transistor. Here you can see, students, that the transistor is operated in three modes. One is active region, one is saturation region, and one is cutoff region. So here if you see the layer diagram of a transistor, say if you speak about NPN transistor, any transistor you can take NPN or PNP. So if you speak about NPN transistor, this is your emitter, this is base, and this is collector. Okay, and this is the junction J1. Okay, so here you can see junction J1. So this is junction J1 and this is junction J2. Okay. Now, if junction J1 is made forward biased and if junction J2 is made reverse bias, okay, then it is in active mode. This is active region. Okay, that is where you use a transistor for amplification process. If you want to use transistor as an amplifier, you have to make junction J1 between emitter and base as forward bias and junction J2 between base and collector as reverse bias. Okay. Similarly, if you go for saturation region, junction J1 will be forward bias and junction J2 also will be forward bias. If both are forward bias, it is saturation region. And if you go to cutoff region, then junction J1 is equal to reverse bias and junction J2 is equal to reverse bias. Okay, that means both the junctions are reverse biased here. Now these two operations, these two regions, that is saturation and cutoff. Saturation will give you transistor in on position, cutoff will give you transistor in off position. So this on and off can be used as a switch, and this is how transistor can be used as a switch. Okay, so in the active region the transistor works as an amplifier, and as a transistor switch it operates in two regions, and they are saturation region where the transistor is fully on and the cutoff region where the transistor is off. Okay, so here I have shown the graph here. So here you can see it is a graph between output voltage, that is between collector and emitter. So here you can see this is collector and emitter voltage VCE versus output current, that is collector current IC. Okay. So initially when you increase VCE, IC will increase, but after that it will remain constant. In all this you can see in first, second, third, fourth, fifth, all the curves you can see that initially the collector current will increase, but after that it will remain constant. Initially the collector current will increase, but after that it will remain constant if you increase the output voltage also. Okay, so this collector current depends upon the input current IB. Input current IB, say this is IB1, this is IB2, this is IB3. Okay, IB4, that is the base current, IB4, IB5, okay, IB6. Okay, so if you increase the base current, the output current also increases. But if you increase the output voltage, output current will not increase, it will remain constant after some time. Okay, now this is your output characteristics of transistor. Okay, output characteristics of BJT, bijunction transistor. Now here if you see this region as shown, this region, if you see, this region is your saturation region. So here you can see your saturation region. This is your saturation region. All this is your saturation region. Okay, similarly, when the base current is zero, a small leakage current flows through the transistor because of reverse bias collector base junction. So here you can see, okay, so reverse bias junctions, both emitter base and collector base junction, there is a small leakage current flowing, and that leakage current is ICO, but there is no main collector current flowing. Okay, so this region will be called as cutoff region. This region will be called as cutoff region, whereas this region was called as saturation region. This region was called as saturation region. Okay, so in saturation region, it is on, transistor is on, and in cutoff region, transistor is off. So here, transistor is off. So these two regions we are going to use for transistor to work as a switch, because in switching action, we want on and off. Okay. So then if you see the diagram of transistor as an open switch first. So this is a circuit diagram for transistor as open switch. So here we have used a NPN transistor. Okay, so NPN transistor is shown over here, and so here you can see NPN transistor. So this is base, this is collector, and this is emitter. Okay, three terminals of the transistor. Now base is connected to 0 volt. Base is connected to 0 volt. That means base current is 0. Okay, so this current is 0 over here. So it will not drive the transistor into conduction. So collector current also becomes 0 in spite of applying VCC voltage. In spite of applying VCC voltage here, collector current also will be 0, and there is no current flowing here like this. Okay, so the transistor is open. The transistor is open. There is no current flowing. It is open like this. Okay, so it is like an open switch. Open switch. So when the base current is 0, and even if you have applied the VCC to the collector, okay, the transistor will not go into conduction because the base current is 0. It will not drive the transistor into conduction, and because of that, it will remain as an open switch. Okay. So here, if you see the note on that, here the operating conditions of transistor are 0 input base current IB, that is what is important, 0 output collector current IC, and maximum collector voltage VCE. If you see the graph of the output, when the collector emitter voltage VCE is maximum, that time IC will be 0, which results in a large depletion layer and no current flows through the device. Therefore, the transistor is switched fully off. So it is an open switch. Okay. If you see the conditions of that, in that open switch, the input and base are grounded to 0. Base emitter voltage VBE is less than 0.7 volt, which is the cut-in voltage. Base emitter junction is reverse biased. Base collector junction also is reverse bias. So both the junctions are reverse bias when the transistor is operating in cutoff region. So here, these both the junctions are junction J1 also and junction J2 also are reverse biased. Reverse biased. Okay. So transistor is fully off. It is cut off. No current, no collector current flows. IC is equal to 0. So here you can see IC is equal to 0, and then V out is equal to VCE is equal to VCC is equal to 1. Okay, transistor operates as an open switch. These are the conditions what take place when the transistor is acting as an open switch. Clear? Then we can also define it. We can define the cutoff region or off mode when using a bipolar transistor as a switch as being both junctions J1 and J2 reverse biased. Okay. Then we'll go to see transistor as a closed switch. So even here the same type of circuit is taken. Here you are applying VCC, okay, through RC to the transistor, and here you see to the base you are applying a voltage VBB. Okay, so base has been applied with a voltage VBB, which makes base current flow. This is going to flow. This is a NPN transistor, NPN transistor. This is your base, this is your collector, and this is your emitter. Okay, when the base current flows here, it is going to drive the base emitter junction into forward bias, and transistor will start conducting because collector current starts flowing and current starts flowing in this direction. Okay, that means it is a closed circuit here. So here it is shown like a closed switch. If you see the equivalent diagram, it is shown as a closed switch. So in this case, whenever there is a base voltage applied and base current flows and emitter base junction is forward bias, then the transistor goes into conduction. And once the transistor goes into conduction, it is a closed path. So it is called as a closed switch. So this is a operation when transistor used as a closed switch. Okay. So here if you see the note, saturation region, okay, because here both the junctions will be forward biased, so it is saturation region. Here the transistor will be biased so that the maximum amount of base current is applied, resulting in maximum collector current, resulting in the minimum collector emitter voltage drop, which results in the depletion layer being as small as possible and maximum current flowing through the transistor. Therefore, the transistor is switched fully on. Okay. So this is the condition when it is in saturation region of the graph. If you see the output characteristics of the transistor, then the conditions for that open switch will be the input and base are connected to VCC. That means full voltage is given to the input and base. Base emitter voltage VB is greater than 0.7, that is cut-in voltage, so it will forward bias. So base emitter junction is forward bias. Base collector junction is also forward bias. Transistor is fully on. It is in saturation region. Maximum collector current flows. IC is equal to VCC upon RL. Collector emitter voltage, that is VCE, is equal to 0. Ideal situation. Okay, when it is 0 only, you get a maximum collector current. Then V out is equal to VC is equal to 0. VC is equal to 0. Transistor operates as a closed switch. Okay, so these are the conditions when transistor operates as a closed switch. Then we can define the saturation region or on mode when using a bipolar transistor as a switch as being both junctions J1 and J2 to be forward bias. Okay, so both junctions J1 and J2 are forward bias, and when it happens, it is in operating in the saturation region, and that is the transistor on mode. Okay, so this is how a transistor can work in a cutoff region and saturation region. So in cutoff region, the transistor will be in off position, that is open switch, and in saturation region, the transistor will be in closed position, that is on switch. So on off operation is possible by properly biasing the transistor. Okay, so this is how the transistor works as a switch. Okay, thank you, students.